Today's lesson, we'll be translating words into symbols. So here they will give you a sentence and they will want you to change it into an equation. So the sentence that they give us is 6 more than a number squared is 30 less than 5 times the number. So in this case, they choose to break down the sentence into different or subdivisions pieces, which makes it a little easier to dissect what they want the equation to be. So like here, they say 6 more than in a box, a number squared in a box, has its own box because that stands for equals, 30 less than 5 times a number. Now here, because of the word less than, remember that tells us to switch our numbers and subtract.
Attention please.
Okay? So that's why in the boxes, your 5 times a number is in the first box, and then 30 is in the back one with the minus attached to it, because it'll be, you're taking that minus 30. So, to fill in the open circles below, 6 more than means that 6 plus something. A number squared would represent x to the second power. It already gave you what equals is. Remember that that is always is. Is and equals are the same thing. 5 times a number is 5 multiplied to a number. Now make sure you're using the same variable unless they tell you otherwise. And then minus 30, just like it sounds. So now putting it all together, I get 6 plus x squared equals 5x minus 30. Okay? So breaking down your sentences into different parts or portions makes it easier to decipher the actual meaning or what the equation would look like in the end. Now, skipping over to an essential part of equations is the thought that we're going to solve. Now, 4 properties regulate how we solve problems. Okay? And there are 4 properties of equality because they're in equations, so they all have equal signs attached to them. So, for each of these, we'll be starting with the same statement, which is A equals B. So if A equals B in the addition property of equality, that's telling me that if I add a number to both sides, which is the same number, then my equation stays the same or equal to one another. So let's take a number example here. If I have 3 equals 2 plus 1, then let's say I add 3 to both sides. So then adding 3, yes, it changes the values on each side, but our equation is still true. So 3 plus 3 gives me 6. 2 plus 1 plus 3 is also 6. So both sides are still equal. So same thought process for subtraction. I'm going to subtract the number that is the same for both sides, which keeps my equation the same, or equal. So let's say we have 8 equals 5 plus 3, and my C is 2, so I'm going to subtract 2 to both sides. Okay? So even though it was 8 equals 8, now 8 minus 2 is 6, and 5 plus 3 minus 2 also gives me 6. The next one, I have A equals B, but I'm using the multiplication property of equality. So I'm going to multiply both sides by the same number to keep my equation the same. So here, let's say we start with 9 equals 3 times 3. And let's say my C value is again 2. So I multiply 2 to both sides. So in this case, 9 times 2 is 18, and 3 times 3, which is 9 times 2, gives me 18 as well. So therefore, the equation stays true. Now for this last one, division, just like it sounds, I'm dividing a number to both sides, so therefore my equation stays the same. So here, let's say I have 21 equals 7 times 3. And let's say I divide both sides by 7. In doing so, 21 divided by 7 gives me 3, and 7 times 3, which is 21, divided by 7 gives me 3 as well. So these properties dictate our equations and keep our equations true no matter what we are doing as we move stuff around to solve for certain variables. We'll talk about more of this in a later section. Have fun!